Hopefully that is starting. Can everyone see that first slide? I hope.
Yes.
Okay, although I see, I don't know if your screen is like mine, but the right side gets cut off. But anyway, okay, thank you very much for this opportunity. My name is Beth Scott. I'm a professor of ecology, marine ecology at the University of Aberdeen. And I'm here today to talk to you about the impacts of offshore renewable energy on its extraction on marine life. And I like to use this scene from a paper from a few years ago. You look at it from left to right, and it shows us what life was like, how we used our oceans in the past, how we're using them about now in the present. And as we're getting to this right-hand side, how we're going to use them, how busy our oceans are actually going to get. So my next slide is showing you actually a satellite image of a delta. And the reason I'm doing this is because I'm trying to talk about the fact that these places are really highly used for people use them. Our big cities are in our deltas, and that's just history, because we used everything by transporting ships. We had ports, and then of course cities grew up around ports. But these areas are some of the most fertile in the world, and I think if we could do it all over again, if we had the planet to shape again, we wouldn't quite do it that way. And that's where we are in the marine world. We're at that spot where we're about to really make huge amounts more use of our oceans for human use. And I'm asking, can we please plan it a little more sensibly than we did the terrestrial world? And so I'm going to do this by going over this range of environmental issues that are out there. And I'm going to focus in for a few minutes on some pragmatic science, I'm calling it. It's a science group of my research group is doing, where we're trying to predictably link the physics of the oceans to animal behaviors, to really quickly understand, both from the fine scale and ecosystems, what's going on in a quick way. And what I want you to think about during this talk is how we can all do this together, because we really need to do it together. So one of the reasons we can do it together is the laws have changed. And if you're not sure about this, go look at our Marine Acts. And the idea there now is stakeholders must get involved for marine planning and to go towards something that's called good environmental status. Now, this is a proactive way we're trying to get our oceans. The whole process has to be stakeholder led. So the idea here is this is much like our global development goals. We have these 11 big goals in our oceans, and some examples are biodiversity, having sustainable commercial fish stocks, or dealing with our marine litter. So I'll come back to this at the end of the talk. What I'm also going to ask you to think about is, are the way we're doing our current environmental impact assessments, are they really fit for purpose for offshore renewables? So this is a picture I took when the environmental impact for one of the Moray Firth wind farms showed up on a forklift. And the idea is maybe we could do a bit better in how we're doing right now on trying to mitigate some of the environmental effects more effectively. It's a hard job because this is the horrendogram of all the laws that are involved in offshore renewables. So what I'm going to do is really narrow it down to the thou shalt not rules about animals in particular. So what I've done is I've narrowed it down to the main focus of these 3 Ds of environmental impacts, I'm calling it. So disturbance, displacement, death. So starting with disturbance, I think all of you have been on any kind of whale watching or bird watching, know that animals will react to boats and things and swim away. And it doesn't seem such a big deal. And it's not such a big deal unless it happens repeatedly and repeatedly. And these animals start to not be able to feed very well. And that could happen to affect their reproductive success. The next thing then is sort of like permanent disturbance, is displacement. Well, so what I'm showing here, this is an image from radar data showing birds avoiding wind farms. And the idea here is that it's, again, if it's just during the annual migration and the birds have to go around twice to this wind farm and they're not going through it, so they're not colliding, it's not that big a deal. But if a bird has to go every day around these wind farms to go feed, it becomes a big deal. And for underwater turbines, for tidal turbines, say in the Pentland Firth, I'll show you about later, if too many of them go in, they could block the area and some animals may see them as a barrier effect. And there's been some evidence showing that actually if you take the energy out of the tides like that, that you change the currents a bit so larvae don't disperse as well. And then of course the last one is collision. These are all long-lived species we're dealing with. So as soon as you start killing some of the adults in the population, that is going to have huge population effects. So these are thou shalt not laws that need to be thought about in environmental impacts. And they're under things, if you're interested, the Habitat Bird Directives and the Natura sites. And these are all now under also ideas of good environmental status. So what I've also done is I work a lot with engineers, and I see that there's a huge area of working together between ecology and engineering, where we could look at each of the design stage of the offshore renewable developments and see how we could mitigate impacts. And so what I've done is color code. The lighter the color, the less kind of impact I think there is, and the darker the color, the more impact. And then I've also brought in cumulative effects, which as you'll see, we start to get to a large number of developments. It's really important. So I'll start with the first one, just the design, just the materials we're using, the amount of power we're going to take out. In a workshop I was in not long ago, the industry talked about biofouling. Biofouling is subsea's dirty little secret. This idea that you put anything in the ocean, stuff will grow on it. So if you know your enemy, can you grow your enemy? The idea is, how about being able to put a seed onto the material that you've got, what you want to grow, so you can come back and harvest it. And of course, then there's all kinds of things you could do with multi-use of these sites, that potentially the use of aquaculture and mariculture that could happen. And there's a lovely book on it if people are interested. So moving on to installation. This is when you get a lot of noise and the pile driving of pylons going in. Well, there's been quite a bit of research done on this now, and across birds and mammals, for most part, it looks like absolutely when the noise is happening, things are going to be disturbed, and there is then ability for any kind of collision with the vessels that are going on, or damage to eardrums if they're too close that can end up in death. But for the most part, it looks like animals move away while the noise happens and then tend to move back rather quickly afterwards. And that's fine if just a few operations are going in. But if we've got things going in all over the North Sea, noise travels very far. That might be quite an issue. And then there's maintenance, which I didn't color very dark, but actually this study came out. So SNH has been up in Orkney at the European Marine Energy Center called EMEC the last 10 years plus, and been looking at wildlife while they've got their tidal testing and their wave sites up there. And what they've shown is that after 10 years, it looks like the biggest impact is when the vessels are present, i.e. just when they're doing maintenance, not so much the operation. So that is worrying, that indeed disturbance might be a little more than we thought. One of the most fascinating things coming out is seeing some marine mammal foraging changes. So what you can hopefully see on your right-hand side here is a grid with a lot of dots on it. And that's some tagged seals that after the wind farm went in, completely changed their behavior and started to forage just around the pylons of these wind farms. So great for seals, but why are they doing that? Well, fish have changed their behavior, and I'll tell you more about that in a second. So what happens in Germany, where a lot of wind farms have been put in? What you have is you have the before from looking at one of the most sensitive birds out there, divers, you call them in this country. I'm Canadian, I call them loons. And what you see is before all the wind farms went in, they were quite big areas where groups of them were foraging. But after the wind farms have gone in, they're now all foraging in the same spot. Now, potentially, it's also because their prey has moved. We're not sure exactly why this is happening. And we're worried now there's a bit of what's called density dependence. They're now all going for the same prey. So it's starting to look like we really need to understand about fish, because also now as we get to operations stage, what we know is that a lot of these things, they make some noise above the water, but generators also make noise below the water. And tidal turbines are actually a bit noisy underwater. And what we see in this particular work, where they looked at the amount of times that a tern was feeding, is we see quite clearly, if you're looking at blue line on this graph, blue is outside of the wind farm, red is inside, and then it's years after the wind farm's been in the operation. And you see that these animals are not feeding as well post operation. And potentially, again, what's happening there? It's the fish species, their prey, that's not coming back to these areas like they used to before the operation. Fish has not been studied as well. So that's why I'm now going to dive in for a couple of minutes into what my research group does, which is trying to come up with ways to actually look at what the fish do underwater. And that's actually pretty hard to do. So what we work with is acoustics, these instruments that bounce sound around in the water, not very noisy, not like sonar. They bounce sound around, And we put them in upward facing places so that we can see both the predator and the prey, the fish shoals, and what they're doing underwater. And you can see here from this example that we're working directly with the tidal industry here with MyGen and putting our instruments on their devices as they go in the water. And this particular work won our postdoc the Green Awards. So what that was showing is that absolutely fish are changing their behavior around structures in the sea. And if you can see it, what I'm trying to show on the right-hand panels is the top panel is without a structure of a turbine and the bottom panel is a structure with a turbine. And the colors that you're seeing is the amount of fish at different depths. And you can see without doing any fancy statistics that fish change their behavior quite a bit around these structures, which might mean it's why we're seeing seals feeding around wind farms. It's why we're seeing things change in terms of the predator-prey interactions in these areas. And that might change the initial assumptions about collision risk in some of these areas. So what we've also done is we've worked a lot with Marine Scotland Science and used their boats like the Alba here. And we've gone out with those same types of instruments you can have on boats looking down. And we've worked in places like where there's fast tides and up at EMEC. And what we're showing here is that when we look at the animals and how the animals are using the physics and why they're changing where they're foraging, is what we're showing is this example is the puffins love water that's fast and coming upwards, these big boils you get in some of these areas. And this little red spots are where the puffins, there's way more puffins feeding. And that changes, of course, on the tides. So it gives us this exact fine scale information. So what we've been doing is putting that all together and using these fancy models that what you're seeing there moving around is the tides in the Pentland Firth. And then we use these boat surveys and we have these upward facing platforms. And what we're trying to do is put that all together to be able to predict areas that are going to change after you start extracting energy out with tidal turbines, but the same with wind turbines. And then we can look at this change in predator prey and we can make it predictive. So we can make it quite inexpensive to start to do this because it's the same kind of data that the engineers need to collect when they are creating these, collecting data for their sites. So let's move on then to what happens when we get to the big scale. So this is an image of wind farms. All the little white dots are wind farms as an artist's impression of 2050 in the North Sea. And I think anybody can see that we are getting to the point where there are definitely going to be ecosystem level effects. When we start to put this many structures in our oceans, we have this many boats and vessels going out to maintain these places. And we've got that much, hundreds of gigawatts of energy being taken out of our oceans. So our oceans don't mix as much when we take that energy out. So these are the kind of cumulative effects we've got to look at this large scale. So what we've done research-wise, we teamed up with oceanographers, and what they've done is an interesting study where we took 6 gigawatts out. Now remember, 1 gigawatt is about the size of a nuclear power plant. Okay, this is a lot of energy. So you're taking that out, you'd look on the panel on the left-hand side, taking 6 gigawatts out, these panels on the right-hand side, the first panel tells you how much the mixing of the oceans has changed by taking those 6 gigawatts out. And it's kind of scary to see how far away from Scotland some of these effects actually happen. But if you look at that range there on the legend and you see the number 6, that's how much that change in mixing is happening. When you then compare it to climate change, in 2050, what you see is a huge difference with climate change. Plus, look at that axis and the circle, that's 60. That's 10 times more of an effect. If you put the two of them together on the far right-hand side, what you cannot see really the difference in climate, in the extraction of energy from the renewables versus climate change, just in 2050, okay? 30 years from now. What we can do then is we can take that kind of information about how the physics is changing. We can use some really fancy spatial models where we can put our predator, in this case a kittiwake, and a prey, the sand eels, we can put them in a model together. And what I'm showing in that first panel down below is where right now those two things overlap. The more purple, dark purple it is, the more they overlap. Then we can put in all that information about 2050 and extracting energy from tidal turbines and climate change. And we can look at what happens to kittiwakes and sand eels. And you can see there's quite a dramatic difference in 2050 already in where they overlap. And an easier way to look at that is now do a color difference of now blue is, the darker the blue is the less they overlap, and the darker the red is the more they overlap. And what you see is the North Sea is not looking that great in 2050 for the overlap of sand eels and kittiwakes, except for a few spots. But the North and the West is looking pretty good. And when we compare this with climate change is still 10 times worse than taking out that huge amounts of energy. So we're almost done, and we're going to look at a mind game right now, thinking about climate change and ecological change. So if ecological change is on your y-axis and time or cumulative effects are on your x-axis, we know that climate change is going to have huge effects. Right now, what we're doing with those EIAs for renewables is we're pretending the baseline's not changing, and we're trying to find out the effect of renewables against today's climate. What I suggest we really should be doing is looking at how much climate change is dampening, or renewables, sorry, is dampening climate change. That at the moment is not allowed in our EIA approach. And I think it really needs to be in there. We really need to think about changing some of our policies. So we can really reconsider how we assess environmental effects, and that then we don't just have ecological costs, but we can also look at ecological benefits and look at a whole ecosystem level when we are trying to build out and design which are the right kinds of places to extract energy out of and put wind farms in or put tidal turbines in. And we need to connect these up with good environmental status. And therefore, everybody can be part of this process. And luckily, we've got these wonderful new economics, the economics of diversity, a fantastic new review that really looks at the heart of this, how we bring the ecology into all of these things like levelized cost of energy, LCOE, and gross value added estimates, so that the ecology comes into the economic equation. And I think that's it. And yes, at the end, I'll be looking forward to your questions. Thank you very much. And I will stop sharing. There we go.